Hi, this is Derek Daly, and this is my S4 Summit video. Let's get right into it. Here is our completed circuit. How did we get here? Well, I'm glad you asked. I'll show you. Let's start with our problem statement, and pretty much what that is to create a functioning stoplight similarly to the one shown in the slides, except with JK flip-flops. So, now that we know this information, we can draw our state diagram, which is shown here. So we have our inputs, x of e, which is for the emergency input, and then x of t, which is for our timer input. And essentially, the timer, when it is high, kind of acts like how you'd expect a stoplight to work. So we have our three states, green, yellow, and red, and you see every time the timer is high, it just goes to the next state and loops back around. We have our x of e, which is our emergency switch, and essentially whenever that's high, whatever state it is on, it'll immediately jump to red and stay on red while that is high. And then obviously if no inputs are high, then it'll stay at that state. So now that we know how this stoplight will work, we're able to create our present, next state, and our required flip-flop inputs as shown here. Check that out and pause it if you'd like. There it is. And then from there, we are able to create our derived equations using Carnot maps. Here we go. And here is our equations right here. And I'll go ahead and discuss why this is a Moore machine and not a Mealy machine right here. And that's because the outputs don't have any inputs in it. It's purely a function of the memory. So that is why this is a Moore machine. So now that we have that defined and each part of the process is outlined, here is our completed circuit yet again. And I'll go over it while it's functioning. So obviously nothing's going to change when the inputs are low. As you can see, we're on green. And when the timer is high, every time that clock edge goes from low to high, it'll switch. Exactly how you'd expect it to from the state diagrams. So we'll let that cycle through till it gets back to green. Alright. So now let's demonstrate the emergency switch. So it should go to red. Let's see. Beautiful. Alright, so it functions exactly how you'd expect it to. And as far as the complexity of the next state logic goes, when using JK flip-flops rather than T flip-flops, there wasn't a massive jump in complexity. The way I thought of it is just instead of one input into the flip-flop, there's two. But yeah, it doesn't really add too much complexity, maybe like a few more wires. But yeah, pretty much that is it. So thank you very much. Have a nice day.